Hey everyone, and welcome. Today, we're diving into quadratic equations. Now, I know that might sound a little intense, but trust me, it's actually like a key that unlocks the solutions to some really cool real-world puzzles. And by the end of this, you're going to see exactly what I mean. So let's start with this question. How can a pretty straightforward construction project, a prayer hall with a very specific area, actually lead us to a fundamental secret in algebra? Well, that's the puzzle we're going to piece together today. And believe me, the journey is just as interesting as the final answer.
Okay, let's dive in and lay out the blueprints for this whole challenge.
So here's the setup. A charity trust needs to build a prayer hall. They know the exact carpet area they need, 300 square meters. Simple enough, right? But there's a catch, a special design rule. The length has to be exactly 1 meter more than double its breadth. So the big question is, what are the dimensions? This is where algebra becomes our best friend. If we just say the breadth is x meters, then that rule tells us the length must be 2x plus 1 meters. And we all know area is just length times breadth. So that gives us this equation right here. X times the quantity 2x plus 1 equals 300. See that? We just translated a real-world problem into the language of math.
And when we multiply that out and move everything over to one side, we get this. 2x squared plus x minus 300 equals 0. And there it is. That's a quadratic equation. You can think of it as the lock on our puzzle box. The answer, the dimensions of our prayer hall, is trapped inside.
But before we try to pick that lock, let's be super clear on what we're actually looking for. We need to find the root of this equation. A root is just a fancy word for a value of x that makes the whole thing true, that makes the left side equal 0. It is the solution. You might have also heard people talk about zeros of a polynomial. Yep, for what we're doing today, it's the exact same thing.
So the big question is, how do we find x? Well, the first key we're going to use to unlock this thing is a really neat technique called factorization. Specifically, we're going to do it by splitting the middle term.
Let's walk through a simpler example just to see how this works. Let's say we have 2x squared minus 5x plus 3 equals 0. The whole trick is to split that middle term, the minus 5x, into two new terms. In this case, we'll use minus 2x and minus 3x. Now, why those two? Because their product, 6x squared, is the exact same as the product of the first and last terms. That's the secret sauce. Once we do that, we can group them up, pull out the common factors, and we're left with two simple expressions. And since they multiply to 0, one of them has to be 0, right? A little bit of algebra later, and we've got our two roots, 3/2 and 1.
All right, the practice round is over. Now let's take this factorization key and use it on the real deal, our prayer hall puzzle.
So, for our equation, that middle term is just x. We can cleverly split that into positive 25x minus 24x. I know, bigger numbers, but it's the exact same logic as before. And when we do all the grouping and factoring, the whole thing simplifies down beautifully into these two factors, x minus 12 times 2x plus 25.
So if we set each of those factors to 0, the math gives us two possible answers for x, the breadth of our hall. The first one is 12. The second one is negative 12.5. Now mathematically, both of those are perfectly correct, but we're building a prayer hall in the real world. Which one actually makes any sense?
Exactly. It's kind of a no-brainer when you think about it. You can't have a building with a negative width. It's a valid mathematical solution, but it's not a real-world solution. So we just use a bit of common sense and toss that negative root right out.
And there we have it. The breadth, our x, has to be 12 meters, which means the length, remember it was 2x plus 1, is 25 meters. And just to be sure, let's check our work. 12 times 25, yep, that's exactly 300 square meters. The puzzle is solved.
That felt good, right? But what if we didn't need the exact dimensions? What if, before we did all that work, we just wanted to know if a solution was even possible? This leads us to an even deeper, more powerful idea.
I'm sure you've probably seen this beast before. This is the famous quadratic formula. It's a powerhouse that can solve any quadratic equation. But here's the thing. We're not actually going to use it to solve anything today. Nope. Instead, we're going to look at a little secret that's hidden right inside of it.
Look closer. I want you to focus on the part that's under the square root sign, b squared minus 4ac. This isn't just a random jumble of letters and numbers, it's actually a secret code.
And this secret code has a name. It's called the discriminant.
Its job is literally to discriminate, to tell the difference between the kinds of answers you're going to get. You can think of it like a master key that tells us about the roots, how many there are, what kind they are, without us ever having to do the hard work of actually finding them. So, let's see how this incredible secret code actually works and why it's one of the best shortcuts in all of algebra.
You know, it's actually super simple. There are only 3 rules you need to know. First, if the discriminant is a positive number, that means your equation has 2 different real solutions. Done. Second, if the discriminant works out to be exactly 0, you still have 2 real solutions, but they're identical. It's the same number twice. And third, if the discriminant is negative, well, you can't take the square root of a negative number, not in the real number system anyway, so that means there are no real solutions at all. That's it.
Okay, let's put this to the test. Here's a brand new equation. Does it have any real roots? Now, instead of trying to factor it, which might be a total headache, let's just use our new secret weapon, the discriminant. We just plug in the numbers. For this equation, a is 2, b is -4, and c is 3. So b squared is 16, and 4ac is 24. A little subtraction, 16 minus 24 gives us -8.
And what did our rules say? Since the discriminant is negative, we know instantly this equation has no real solutions. We're done. Look how fast that was. We didn't have to struggle with factoring at all. The discriminant gave us a straight-up no in just a few seconds.
And this really shows you where the discriminant is a total game changer. Take a problem like this. Can you put a pole in a park at a specific spot? The geometry of the problem gives you a quadratic equation, but before we even start trying to solve for x, we can ask a simpler question. Is it even possible? Let's check the discriminant. We plug in the numbers and we get 289. Since that's positive, the answer is a definite yes. A solution exists. Now we know it's actually worth our time to go and find it.
So we've seen 2 pretty amazing things today. First, how we can take a real-world puzzle, turn it into an equation, and crack it open with factorization. And second, how this amazing secret code called the discriminant can tell us about the answer before we even do the work. It kind of makes you wonder, doesn't it? What other elegant shortcuts and secret codes like this are hiding in plain sight, just waiting for us inside the language of math? Thanks so much for joining me.